Start.
Hello everyone, my name is Rutuja Kokate. My group members are Prachiti Raut and Shruti Divte. Our HDL presentation topic is implementation of medical image processing algorithm on a reconfigurable hardware. The table of content of our presentation is first is an introduction, second innovative concept of our paper, third is a technology or methodology what we use in our paper, fourth limitation of our paper, for, fifth, result of our paper, and last but not least, conclusion. So first is the introduction. Image processing is an important element of a cancer detection, diagnosis and treatment in a medical application. The problem is to properly extract, measure and interpret this information in order to obtain understanding and insight into anatomy and a function of the organs being imaged. The interpretation of the generated pictures necessitates the use of advanced image processing algorithm that improve visual interpretation as well as the image analysis approaches that allow for automated or semi-automated object detection, measurement and characterization in a medical image processing. The next slide will be continued by Prachiti Raut.
The next point is the innovative concept of paper. Pseudo-color processing used for simulating image processing methods, followed by the potential for quick implementation utilizing the FPGA use. This process of pseudo-color processing convert each of the black and white images into gray each and white images gray levels into a specific color as shown in the figure. When these color images is exhibited, it can be simpler for the viewer to recognize a specific aspect as these images is not clearly visible by human eyes. The mapping are quick and easy to complete. Next slide. The next point is a technology or methodology use. This study uses the hardware description language, that is HDL, and Verilog code to describe and evaluate a pseudo-color image processing method for image enhancement. The first step is the method entails translating a grayscale images onto a color images in which each pixel value is given a unique color. The given image processing algorithm uses an 8-bit field to represent the value of the gray level. To indicate a particular regions, the new palette of colors can be created based on any set of guidelines. As we know, we can convert the gray and white color images into the red, green and blue images. For that instance, the Verilog code shown pixels with a gray label between the 0 and 1. Using a Verilog HDL description, inverting a medical images into the pixel between the 13 to 70 will be displayed in a blue color. Pixels between 71 to 189 will be displayed in a green color, and pixels between 190 to 249 will be displayed in a red color, and the remaining pixels are displayed in a white and 29 will be displayed in a black color. So this is all the methodology is carried out. The next point is the limitation of the paper. The first limitation of the paper was to the key difficulty is to converting the tested algorithm into a language that is not programming language, such as a hardware description language. Then the next limitation is that it is necessary to modify the input and output data files to reshape to the binary content allowed by the hardware simulation. The third point is FPGA are limited when dealing with the entire images since they have a limited memory. And the fourth point is the power usage is high during reconfiguration. The next point will be continued by the Shruti Dute.
So the result from the paper was that Verilog hardware description language was used to define the image enhancement operation. Verilog test benches were used to test the design and ISM simulator was used to simulate it. The Verilog block design used the binary file as a vector. The same application was used to similarly convert the inspect the result file. To improve timing performance, the logic and memory resources used during Verilog hardware implementation were maximized. The following table shows the frequency and time of filter 1 and filter 2 for Xilinx Vertex 6 FPGA ML605. Next slide. The conclusion was that in order to implement the digital image processing algorithms and to process the amount of data captured from sources such as medical instruments, intelligent high-speed real-time systems have become imperative. In this paper, an efficient FPGA-based design and implementation of image processing algorithms are presented using hardware description language. The FPGA provides the necessary hardware for image processing algorithms with flexibility to support medical image processing by using point operations. The proposed pseudo-color algorithm is designed using Verilog HDL, simulated, tested, and synthesized with Xilinx ICE Design Suite 14.5. Thank you for the presentation.